Yeah, this is your lesson on trig functions, and today we're going to talk about angular and linear speed. You will calculate angular and linear speed. Also, I'm going to tack on a little bit here. We're going to be finding central angles and intercepted arcs. All right. First, let's talk about linear speed. Linear speed is what you're kind of used to. Like if you're running 6 miles per hour or you're driving 40 miles per hour, that's linear speed because you're going in a linear path and your units are going to be in linear measurements. Okay, we measure miles or feet or inches in linear measurements, and that's speed, so that's per hour. Now, angular speed is the angle on how fast an angle is being moved, and the hour hand on a clock moves at 6 degrees every minute, because while the minute hand goes around one full circle, the hour hand only moves one little tick, which is 6 degrees. So it moves 6 degrees every minute. And you can think of angular speed as how fast you open a door, because it's hinged at the corner and you're opening it and you're deciding how fast you can open that door, but you're not actually moving a linear distance. Okay, so that's the difference between angular speed and linear speed. Okay, you can have linear speed if you're running like wrapped around a round track or running around the clock. All right, that will still be linear speed because you're going to be running in like inches per second, maybe in those kind of measurements. But if we're talking about angular speed, we're talking about how fast it's moving around the circle as far as angle. We're measuring the angle, and this is we're measuring the distance. So this is distance speed, and this is angle speed. All right, so here we have a problem. We have a wheel that has a diameter of 3 feet, and it rotates at 60 revolutions per minute. 60 revolutions, a revolution is 1 time round. So if you put a mark on your tire, it will go around 60 times every minute. That would be the definition of revolutions per minute. So we're going to do 2 parts here. We're going to find the angular speed in radians per second. We're also going to find the linear speed in feet per second. Let's do the first part. We're going to find the angular speed in radians per second. What we're given is that the wheel rotates at 60 revolutions per minute. So 60 revs per minute. We're also given that the diameter is 3 feet. Okay, that's the only information we're given. So, but what are we trying to find? We're trying to find the radians per second. Radians per second. We don't know what that is. So we're going to need to convert from revolutions to radians. That's the math that we're going to be doing. We'll also need to convert the minutes to seconds. I think we know how to do the minutes per second to seconds, but let's concentrate on the revolutions per to radians. We know the equivalent of 1 full circle is 2 pi radians, is 1 full circle around. That's the radian measure. 1 rev is equal to 1 revolution, so that's my conversion factor. Okay, let's begin the math here. I have 60 revolutions per minute. I'm going to multiply it by some kind of conversion here. And this is a ratio, so I can make that as a fraction. And we're going to put the revolutions in the denominator because we want that to cancel. If we had revolutions in the denominator, then we want this upside down because we want to be able to cancel the revolutions up here with the one on the bottom. But since we have one on the top, we need to cancel the one on the bottom. And then we can cancel those. That's why we put the radians on the top and the revolutions on the bottom of the fraction. And then we need to convert the minutes to seconds. We know that there are 60 seconds in 1 minute. So we put the minutes on top so we can cancel those. And now we just have to do the number parts of it, because now our answer is going to be in radians per second. I know that the 60s can cancel because one's on the top, one's on the bottom. And basically we're left with the answer. And the answer is going to be 2 pi radians per second. That's how we do part A. The hardest part right here, or the new part for you, may be this right here. Okay? Alright. Now we're going to do part B. We're going to find the linear speed. We're going to find how fast this is rotating around. If you were on the edge, how fast would you be spinning? Okay? So if we're going to do that, we're still given the same information, but this time we're trying to find feet per second. So we need to convert the revolutions to feet, and also we need to convert the minutes to seconds. So revolutions to feet, we're going to need a formula that we had a long time ago. The definition of pi is the circumference over the diameter. So circumference all the way around the edge, that's what we're trying to find, is equal to the diameter times pi. And in this case, the diameter is 3 pi, and we just have the feet, right? 3 feet per revolution, because the circumference is 1 revolution. So this is my conversion. So I start with 60 revolutions per minute, multiply that by 3 pi feet per revolution, because now I have 1 in the numerator, 1 in the denominator that I can cancel. Now I just have to get rid of the minutes and replace that with seconds. So that's 1 minute for every 60 seconds. Reduce the minutes, reduce the 60, and there's basically my answer here. 3 pi feet per second. Okay. All right. I hope you took good notes, because now you're going to do this one. Okay. Pause the video and come back when you have some answers for me. All right. So if you've done here, we're going to find the angular speed. We're given 450 revolutions per minute. We're given 8 centimeters in the diameter of my wheel. We're trying to find radians per second, so we need to change my revolutions to radians and my minutes to seconds. So now I'm going to use the same conversion here. Multiply by 450 revolutions per minute times my conversion, cancel, change my minutes to seconds, cancel, and then we can't cancel the 60 and the 60, but we can reduce. We can reduce that to 15 and 2. We're going to reduce it by 30. Okay, so and then the 2's will cancel, and I'm left with 15 pi radians per second. And if you multiply 15 by 3.14, you'll get approximately 47.12 revolutions per second. This is the exact answer. This is a rounded answer. This answer looks better in real life, but this is more of a mathematical answer because it's more precise. But lay people do not like seeing the pi because it's confusing. But math people, that's perfectly fine. And now, part B, the linear speed. Alright, so basically have the same start given information. We want now meters per second. Okay, now we need to change revolutions to meters, and we need to change minutes to seconds. So now we're going to do kind of the same thing here. And we have revolutions, and then we're going to multiply that, and we're going to get all of that. And we also have to convert the centimeters to meters. So we have one more conversion that we didn't have before, because the diameter's in centimeters and the requested units on the answer was meters. So there's 1 meter for every 100 centimeters. Centa means 100. And then cancel my centimeters and get a final answer of 1.88 meters per second if we multiply that out with the pi. Okay. All right. Now instead of a clock, we have a lawn roller. Okay. This is if you're like working in a yard, or parents work in the yard and you've planted a new lawn, you know that they either have one of these if they do this a lot, or they rent one. It's just an empty drum, and they fill it with either rocks or water to make it really heavy. And then when you plant a new lawn, you level out everything, and then you pull this with I don't know, if you're doing a really big area, you might use a tractor, or you just hand pull this, and this heavy round barrel will level everything out like a steamroller. Okay, level out the ground, getting ready for the lawn. So we have a lawn roller with a 10-inch radius. So the radius is 10 inches, and it makes 1.2 revolutions per second. Find the angular speed of the roller in radians per second. So now we're going to do this the same way as we did the last one. See if you can finish it on your own, and come back and check with me and see if you can get the answers. All right. We are given (1.2 revolutions per second), and we are given that the diameter is equal to 2 times the radius, and the radius is 10 inches, so the diameter is 20 inches. Okay, the diameter is all the way across, and the radius is only halfway across. Now we want to find revolutions or radians per second from revolutions per second. So we don't even have to convert the time this time. We don't have to convert the minutes to seconds. So we're just going to use my conversion here. We're going to multiply that by 2 pi radians per 1 revolution, cancel, and we get 2.4 pi, or approximately 7.61 radians per second. Doing the speed of the tractor that's pulling this heavy barrel, we get 1.2 revolutions per second. Okay, and here's my diameter, and we're going to change revolutions to inches. So that's going to be my circumference. So it'll be 20 pi over 1 revolution, and then divide, and we get 123.2 inches per second. All right. Oh, that's coming in the wrong time. All right, we're done with angular and linear speed. We're going to jump over to central angles and intercepted arcs. A central angle is an angle that has a vertex at the center of a circle. So this is a central angle. So if you're taking notes, you can write down that the central angle has a vertex at the center of a circle. And the intercepted arc is that piece of the circle that gets cut off by that angle, the intercepted piece of the circle, or an arc. This is an arc, and it's a piece that's related to the central angle. So those are the two pieces that we're going to be talking about, and there's a formula for that. And the formula looks like this. It's a proportion. It's the part of the arc over the whole circle and the part of the angle over the whole circle. Okay, this is a proportion, part over the whole, part over the whole. Part of the linear part over the whole linear part is equal to the part of the angle over the whole of the angle. Now, this looks a little confusing here, but it's 2 pi or 360 degrees, whichever units they happen to give you for theta. Okay, whichever value they give you for this angle. If they give this to you in radians, then you use 2 pi. If they give this to you in degrees, use 360. All right, let's try one. By the way, this is the circumference all the way around one full circle. Okay. All right, let's try one. So we have an intercepted arc of 15 centimeters. That means if this was a piece of string, we laid it out flat, we can measure that as 15 centimeters. And the radius of the circle is 10 centimeters. So we're trying to find the angle here because that's what's missing. All right. So we have all the pieces here. We have theta that we're trying to find. That's the unknown variable. And then we have S, that's 15 centimeters, and we have R, and pi is a constant number. All right. So in this case, I'm going to actually do this in radians because it's a little easier. We're going to put in the 15 for S and 10 for R, and we just simplify this. Now, I don't know if you know that you can reduce fractions up and down, but you can also reduce cross this way. You can reduce all the way around the equal sign. You just can't reduce like from here to here. You can't reduce the 15 with this. If let's say this was a 20 and a 2, you cannot reduce diagonally across because that's the way you're supposed to multiply in a proportion. You multiply diagonally in a proportion and you cancel around the equal sign. All right, so I'm going to first cancel the 2 pi's. And then I'm going to, like I reduce the 2 pi's, I get a 1 and a 1. I can reduce the 15 and a 10, and I get 3 and a 2. So that means theta is equal to 3 over 2 because I've canceled everything else out. And because I used the 2 pi, now the units on this is radians. I don't even have to write radians. It's automatically assumed that any angle is in radians unless you have a little degree symbol. If I had used the 360 down here, I would not have been able to cancel with this 2 pi in here. Wouldn't have been as clean, but it would have been in degrees at that point. Okay. All right, let's do another one. Okay, try and do this one. Pause it. And if you get stuck, you can look at little pieces of it at a time, get little hints, and then see if you can come up with the answer before I put up the answer. So now the arc here is 11 and the radius is 7. So I'm still going to try and do this in radians, okay? Because I like canceling those. It makes it nice and neat. So the angle is 11 over 7 radians. How's that? Did you get that? I hope you did. All right. Now let's try one where I'm given the angle and I'm trying to find the piece up here using this exact same thing, except the only difference is now that I have to use the 360 because this angle is given to me in degrees instead of radians. So putting that all together, I get 105 up here, and I have to use the 360 because the units have to cancel. The degrees and the degrees have to match. And I don't have S. I know what 2 times 3.14 times 5 is. In order to solve this, I need to get S by itself, so I need to get rid of this denominator. I do that by multiplying by 2 pi over 2 pi times 5, so I can cancel that, or 10 pi, right? This is 10 pi and that's 10 pi. Those cancel, and whatever I do to one side, I do the same thing to the other side. So multiplying all this out, I should get S is about 9.16 meters, and that meters comes from the radius being in meters right here, because all the other units went away. Ready to try one? All right. You try this one, okay? try and find, this is now in radians, so be careful you're not using the degrees. You're going to use radians because this doesn't have a degree symbol. We're trying to find S. Okay, you finished? Alright, let's see. You have S over 2 pi times R, which is 24. And then theta, the angle, is 6 pi over 5 over 2 pi. Multiply both sides by 48 pi. Or actually, I don't have to because the 2 pi's cancel. Hey, I like that. Okay, cancel the 2 pi. Cancel the 24. Okay, that's why I multiplied by 24. Whatever I do to one side, do the same thing to the other side. And multiplying that out, I get the intercepted arc is 90.48 inches. Okay, that's it. So make sure you answer the Google form.